Okay, welcome back. In this video we are going to look at what are called bounds of real zeros. Now it seems like an awful lot in the definition here, but essentially what it boils down to is that you have an upper bound and a lower bound when we're talking about real zeros. And you want to know what those bounds kind of are, the guidelines, meaning that your real zeros won't be found outside of them. Well, we have a couple hints. So first of all, we've got our definition here that just basically says that you need a polynomial where your degree is greater than 1. Your upper bound is going to be a bound when your real zero has no negative coefficients, and a lower bound is when you have alternating signs. Okay? So what exactly does that mean? Well, it just simply means this. When we're talking about your lower bound, we are looking at alternating signs of synthetic. When we're talking about your upper bound, we are talking about all positive of the synthetic. Now, looking at bounds, there's really the only way to show it is with an example. So, you want to use synthetic division to identify upper and lower bounds of the real zeros of the polynomials. So, the first thing that you want to do is you want to graph your function on your calculator. The second thing you want to do is you want to use your zeros function to identify all possible real zeros. The third thing you want to do is you want to use synthetic with your largest positive zero and your largest negative zero, and then see what happens. Okay? The last thing to keep in mind is that if your synthetic fails the bound definition, try your next number. Okay, so we're going to look at exactly what that means. So I have the example that says I have f of x is equal to 2x cubed minus 3x squared minus an 8x minus 3. So I need to use my synthetic in order to find it, and so I need to remember that my lower bound is alternating signs and my upper bound is all positive. Okay? So I'm going to go ahead and I'm going to use my calculator in order to graph it. And when I do that, first I find that I have my possible zeros to be 3, negative 1, negative 1/2. So the first thing that I would do is I would go ahead and test for my upper bound. So here I'm going to look for my upper. So I'm going to test synthetic using my highest positive 0. which is the 3. Now with that I have my function here, so I need to go ahead and use those coefficients. So I have 2, negative 3, negative 8, negative 3. I need to drop down my 2, and what I'm hoping is that I end up with 0 on the end, or that I at least, well, not that I have 0 on the end, but that all of my terms down here are positive. Okay, so 2 times 3 is 6. Add these together and I get 3. 3 times 3 is 9. Add these together, I get 1. 1 times 3 is 3. Add these together, I get 0. So, if you look purely down here, what you will notice is that all coefficients, remember that's the numbers, are positive. Since they're all positive, what that means is that my upper bound is 3. So I'm done with the upper. Now I can look at the lower. So my lower, I want to use the largest, most negative. So I have 2 negatives here, negative 1 and 1/2. I'm not going to use 1/2, so I'm going to look at negative 1 because it's a larger. I mean, I know technically it's smaller, but for all intents and purposes, 1 is bigger than 1/2, so we would use it. Essentially, you're looking for the number that's further away from the origin. Okay, so that's what we're doing. And again, we got to start from the beginning. 2, negative 3, negative 8, negative 3. Drop down your first term, and now let's see what happens. 2 and negative 1 is going to give you a negative 2. Add these together, and we end up with negative 5. Negative 5 and 1 is a 5. Add these together, I get a negative 3. Negative 3 and negative 1 is 3. Add these together, and I get 0. So again, we want to look down here, and you're going to notice that this is not alternating signs. So this means I have to test using another number, okay? So I want to use a number that is going to be even further away from the origin. So because negative 1 did not work, now I'm going to go ahead and I'm going to test negative 2. And this is how you do it. You just keep repeating and keep testing your values until you get one of them that satisfies that definition. So let's see what happens when we use negative 2. So negative 2 and 2 is going to give you a negative 4. Add these together, you get a negative 7. Negative 7, negative 2 is going to give you a 14. Add these together and you get 6. 6 negative 2 is a negative 12. Add these together, you get a negative 15. Now remember I said we don't care about this being a 0. What we care about is are we alternating signs. So here we go, positive, negative, positive, negative. So again, when you look down here, what you will notice is that your signs are alternating. So what this means is that your lower bound is a negative 2. So in order to write the solutions, your bounds would be the interval from negative 2 to 3. Whoops. Alright, so that's all there is to it with bounds. It's nothing, it's not more complicated than that. It's just simply a matter of being able to determine where the zeros are going to basically lie between. And that's that. So just remember, upper bound means that once you run your synthetic division, all of those numbers should be positive. Lower bound means once you run that division, your signs should be alternating. So if you have any questions, please let me know. If you want to see more examples, let me know that too. Otherwise, enjoy, and I will see you next time.